The sun is burning you right now, not metaphorically, literally. Photons are entering your eyes. Ultraviolet radiation is striking your skin. Cosmic rays are passing through your body, ionizing atoms, creating damage at the cellular level. The sun is a massive thermonuclear reactor, and you're living inside its kill zone. And you need it to survive. Every molecule of food you eat is made of carbon that was captured from the atmosphere by plants. That capture happened through photosynthesis. Photosynthesis is powered by sunlight. The sun is the original energy source for every calorie you consume. The sun is the reason you exist. The sun is the reason any life exists on Earth. But the sun is also slowly cooking the planet. The sun is gradually increasing in luminosity. The habitable zone is moving outward, and Earth is being left behind. We're experiencing a slow-motion catastrophe that will take billions of years, but is happening right now. Every moment, the sun is getting slightly hotter, and every moment, Earth is moving closer to becoming uninhabitable. We're living inside a contradiction. We need the sun to survive, and the sun is killing us. Let me show you what the sun is actually doing. The sun is a ball of nuclear fire. 436 million tons of hydrogen are being converted into helium every second in the sun's core. That conversion releases energy, tremendous, incomprehensible amounts of energy. Energy that radiates outward in all directions. Energy that travels through space at the speed of light. Energy that reaches Earth in 8 minutes and 3 seconds. And when that energy reaches Earth, it does two things. First, it powers life. Photons strike plants. Electrons become excited. The excited electrons drive chemical reactions. Carbon dioxide is converted into glucose. Glucose is converted into more complex molecules. Life is built from captured sunlight. We are made of the sun. Second, the sun's energy kills us. Ultraviolet radiation damages DNA. It causes mutations. It causes cancer. It strips atoms from molecules, ionizing them, creating free radicals. The sun's radiation is lethal. Our bodies are constantly under assault from solar particles. The only reason we survive is because Earth's atmosphere and magnetic field protect us. They filter out most of the radiation, but that protection is imperfect, and it's temporary. The radiation still gets through. Every year, thousands of people die of melanoma, skin cancer caused by ultraviolet radiation from the sun. People with sun exposure experience premature aging. Their skin becomes damaged, wrinkled, weathered. The sun is aging us. The sun is killing us slowly, and we can't escape it. We can't hide. The sun is always there, always radiating, always delivering energy and death in equal measure. We're dependent on it, but we're also victims of it. It's a parasitic relationship. The sun keeps us alive just enough to keep killing us. But here's what's genuinely terrifying. The sun is getting hotter. Not today, not this year. But over millions of years, the sun's luminosity is increasing. It's a natural part of stellar evolution. As the sun ages, as hydrogen is converted into helium in the core becomes more dense. The density increases pressure. The pressure increases temperature. The higher temperature makes the nuclear fusion process more efficient, and more efficient fusion means more energy output. The sun is brightening slowly but inexorably. It's brightest about 1.1 times the solar luminosity it is today, which doesn't sound like much, a 10% increase, but 10% more solar radiation reaching Earth would be catastrophic. The greenhouse effect would intensify, the oceans would warm, clouds would form differently, precipitation patterns would shift, the climate would destabilize, and that increase is coming. Not in thousands of years, not in millions, but in about 1 billion years, the sun will be 10% brighter than it is today. And Earth will become uninhabitable. The oceans will evaporate. the atmosphere will become saturated with water vapor, a runaway greenhouse effect will activate, and life will end. We have about 1 billion years before the sun cooks us to death. But that's not the immediate problem. The immediate problem is that we're already running out of time. Let me show you something that should disturb you. 3.5 billion years ago, when life first emerged on Earth, the sun was dimmer. Significantly dimmer. About 30% dimmer than it is today. The sun was putting out only 70% of its current energy output. Scientists call this the faint young sun paradox. The paradox is this: if the sun was 30% dimmer, Earth should have been frozen. The planet should have been covered in ice. The oceans should have been frozen solid. But the geological record shows that Earth had liquid water. The planet had a relatively warm climate. Life emerged and thrived. How is that possible? The answer is that Earth's atmosphere was different. It contained more greenhouse gases, more carbon dioxide, more methane. Those gases trapped more heat. They compensated for the sun's dimness. They kept Earth warm enough for life. But as the sun got brighter as it aged, as the luminosity increased, the greenhouse gases were consumed. Life evolved to use atmospheric carbon dioxide. Plants removed CO2 from the air during photosynthesis. Bacteria broke down methane. The greenhouse gases decreased, and the climate remained relatively stable. We maintained equilibrium. For billions of years, the sun was getting brighter, but life was removing greenhouse gases. The two processes balanced. The climate stayed habitable, but the balance is breaking. The sun is getting brighter faster than we can remove greenhouse gases from the atmosphere. And now we're adding greenhouse gases instead of removing them. We're burning fossil fuels. We're increasing carbon dioxide. We're intensifying the greenhouse effect, which means the balance is completely shattered. The sun is brightening. The greenhouse gases are increasing. And the climate is accelerating toward uninhabitability. We're speeding up the process. We're moving the timeline forward. The point at which Earth becomes too hot for life, the point that should be about 1 billion years in the future, we're accelerating it. We might have reduced our window to only hundreds of millions of years or less. But let me show you the immediate problem. The thing that's happening right now, the habitable zone is moving. The habitable zone is the region around a star where planets can maintain liquid water. Not too close, too much heat, not too far, too much cold. Just right. And for Earth, for billions of years, we've been in that zone, but the sun is brightening. And as the sun brightens, the habitable zone moves outward. The inner boundary, the closest distance at which a planet can maintain liquid water, moves outward. The outer boundary moves outward too. The entire habitable zone drifts away from the sun. And Earth is not moving outward. Earth's orbit is fixed by the balance between Earth's gravity and the sun's gravity. We're at 150 million kilometers from the sun. We stay there. We can't move. We're locked in orbit. Which means, as the habitable zone moves outward as the sun gets brighter, Earth is getting closer to the inner boundary of the habitable zone. We're getting too close to the sun. The heat is increasing. The oceans are warming. The climate is becoming unstable. Eventually, in about 1 billion years, maybe less, Earth will move inside the inner boundary. We'll be too close. The heat will be too intense. The greenhouse effect will become unstoppable, and the oceans will evaporate. We're slowly drifting into the sun's kill zone, and there's nothing we can do to stop it. We can't change Earth's orbit. We can't move the planet outward. We can only watch as the sun ages and brightens, as the habitable zone moves away from us, as we're left behind, baking in increasing heat. It's like being on a ship and the ship is sinking and the lifeboat is moving away and you can see it happening, but you can't do anything to stop it. But here's what makes this even more disturbing. We don't actually know how much time we have. The sun's luminosity increase is predictable. We can calculate it. But Earth's climate is chaotic. Small changes can trigger big effects. The greenhouse effect could accelerate faster than we think. Feedback loops could activate. Methane could be released from thawing permafrost. The oceans could release dissolved CO2. And the climate could collapse not gradually, but suddenly. A runaway greenhouse effect doesn't announce itself. It doesn't give warnings. It starts slowly, imperceptibly slowly, and then suddenly accelerates. And by the time you realize it's happening, by the time you measure the acceleration, it might already be too late. We could trigger it in this century. We could trigger it in 1,000 years. Or we could trigger it in 1,000,000 years. We don't know. The threshold is invisible. We're approaching it, but we don't know how close we are. And that uncertainty is paralyzing, because it means any climate decision we make could be the wrong one. Any choice could push us over the edge, or any choice could save us, and we won't know which until it's too late. But let me show you the other way the sun is killing us: the radiation. The sun doesn't just emit visible light. The sun emits ultraviolet radiation, X-rays, cosmic rays, energetic particles that can strip atoms from molecules. And that radiation is lethal. Earth's atmosphere protects us. The ozone layer absorbs ultraviolet radiation. The magnetic field deflects cosmic rays. These protections saved life. Without them, the surface of Earth would be sterile. Nothing could survive in unshielded sunlight, but the protections are failing. The ozone layer is depleting. We damaged it with chlorofluorocarbons. We've been healing it slowly, but it's still weaker than it should be. And as the ozone layer thins, more ultraviolet radiation reaches the surface, more skin cancer, more mutations, more death. The magnetic field is weakening. We don't know why. It's been weakening for thousands of years, and when the magnetic field weakens, cosmic rays penetrate deeper into the atmosphere, more radiation reaches the surface, more damage, more mutations, and eventually, maybe in millions of years, maybe in hundreds of thousands, the magnetic field might collapse entirely. It's happened before. Reversals. The north and south magnetic poles have switched positions many times in Earth's history. During a reversal, the magnetic field weakens dramatically, and during those periods, the surface is exposed to intense cosmic radiation. Life survives reversals, but barely. Species go extinct, mutations increase. The biosphere becomes impoverished. And if a reversal happens while we're experiencing increased solar luminosity, the combined effect could be catastrophic. We'd be losing both protections simultaneously: the ozone layer thinning, the magnetic field reversing, and the sun getting brighter. The radiation would become unbearable. But that's all hypothetical. That's the far future. Let me show you what's happening right now. The sun is experiencing cycles, 11-year cycles, longer cycles too, 22 years, 88 years, hundreds of years. And during those cycles, the sun's activity changes. Sunspots appear and disappear. Solar flares occur. Coronal mass ejections eject plasma into space. And those events affect Earth. Solar flares can disrupt satellites. Coronal mass ejections can damage power grids. Solar radiation storms can increase radiation exposure on airplanes and in space. And the cumulative effect of solar activity can warm the stratosphere. It can affect ozone chemistry. It can influence cloud formation. The sun is constantly battering us with radiation fluctuations, sometimes gentle, sometimes violent, but always unpredictable. We build structures and systems that assume a certain level of solar activity. But the sun doesn't follow our assumptions. And when solar activity spikes, when a powerful flare or coronal mass ejection hits Earth, our systems break. Satellites fail. Power grids collapse. Computers stop working. We're vulnerable to the sun's tantrums, but we adapt. We rebuild. We design better shielding, we prepare for the next solar storm, and for now, we survive. But what happens when the sun becomes more violent? As stars age, they become more active. The magnetic field becomes more chaotic, flares become more frequent and more intense. Eventually, old stars can produce solar storms so powerful that they strip away planetary atmospheres. They sterilize entire planetary systems. The sun is currently in a relatively stable phase, but it won't last forever. In a few billion years, as the sun ages and approaches the red giant phase, the magnetic activity will intensify. Solar flares will become more powerful. Coronal mass ejections will become more frequent, and Earth's atmosphere will begin to erode. Particles will be stripped away, the magnetic field will be overwhelmed, and the radiation reaching the surface will become lethal. Eventually, after the sun becomes a red giant, after the oceans have boiled, after the atmosphere has been blown away, Earth will be a sterile, irradiated rock. Nothing will live here. Nothing will survive. But that's the very far future. Let me show you something that's happening now. We're dependent on the sun, completely dependent. Our entire civilization is built on solar energy. Directly through solar panels and solar thermal systems, indirectly through fossil fuels, which are fossilized sunlight, through wind power, which is driven by solar heating of the atmosphere, through hydroelectric power, which is driven by solar evaporation of water. All of our energy comes from the sun, and if the sun changed, if it dimmed, if it brightened, if its output became unstable, our civilization would collapse. We have no backup. We have no alternative. We're completely at the sun's mercy.